Welcome back to another video. Here, we will talk about F confidence intervals. The F distribution is a right-skewed continuous probability distribution that is bounded at 0 and is asymmetrical with a longer tail on the right. It is defined by 2 degrees of freedom, one for the numerator, m, and one for the denominator, n. Although it has a very complicated PDF, it can be constructed by finding the ratio of 2 chi-squared distribution divided by their degrees of freedom. The degrees of freedom of these chi-squared distributions define the m and m parameters of the F distribution. F distribution arises frequently in statistics, particularly in the context of comparing variances of 2 normal populations. We previously introduced chi-squared statistics for defining a confidence interval on variance of a single population. Now, we can create 2 independent chi-squared statistics and use them to build a F statistic to compare the variances of 2 different populations. If x1 to xn is a random normal sample from our first population and y1 to ym is our second random normal sample from a different population, we can define 2 different chi-squared distributions as. If we divide these chi-square statistics with their degrees of freedom and find the ratio of these divisions, we will have an F statistic with n-1 and m-1 degrees of freedom. Another interesting fact about F distributions is their reciprocal property. As we just discussed, the F statistic is the ratio of 2 scaled independent chi-squared random variables, each divided by their respective degrees of freedom. So if random variable f follows an F distribution with n and m degrees of freedom, 1 over f would follow an F distribution with m and n degrees of freedom. Now in terms of f values, the value f of alpha with m and n degree of freedom corresponds to the upper alpha percentile of the F distribution with m and n degrees of freedom. Similarly, f value of 1 minus alpha with n and m degrees of freedom corresponds to the lower 1 minus alpha percentile of the F distribution with n and m degrees of freedom. Intuitively, this property reflects the symmetry in the F distribution when considering the ratios of variances. It ensures consistency when degrees of freedom are swapped between the numerator and denominator, preserving the reciprocal relationship between the critical values. Pushing half alphas to each tail of an F distribution, we can claim that probability of an F random variable being between F value of alpha over 2 and F value of 1 minus alpha over 2 with n-1 and m-1 degrees of freedom is equal to 1 minus alpha. Next, we replace the general random F variable with our F statistic and multiply all side within parenthesis with s square of y over s square of x. This will give us a 2-sided confidence interval on the ratio of the population variances, which starts from s square of y over s square of x times f value of alpha over 2 with n-1 and m-1 degrees of freedom to s square of y over s square of x times f value of 1 minus alpha over 2 with n-1 and m-1 degrees of freedom. In addition to the 2-sided confidence interval, we can define 2 one-sided confidence intervals. The one-sided confidence interval with lower bound starts from s square of y over s square of x times f value of alpha with n-1 and m-1 degrees of freedom to infinity. And the one-sided confidence interval with the upper bound starts from -infinity to s square of y over s square of x times f value of 1 minus alpha with n-1 and m-1 degrees of freedom. Let's go over an example together. Students, male and female, have participated in a survey regarding their height. Find the 95% confidence interval on the height variance ratio of the female and male students. To build the correct confidence interval, we need to identify the parameters of interest, which seems to be the population's variances, as the question wants us to find the 95% confidence interval on the height variance ratio of the students. To do so, we need to load the confidence interval f function and pass the required arguments. The backend of the said function will calculate the sample variances and retrieve F coefficients to report the lower and upper bounds of the 95% confidence interval as 0.08 and 0.35, respectively. Thank you for listening to this short lecture on F confidence intervals.